will study now the fourth function in this list, this one, right? The first observation we're going to make of this function is that this function is odd. It's pretty obvious that it's odd because this bit here depends on x squared, so this is even. Let's multiply by x. X changes sign if we change the sign of x, right? So this function is odd, which means that we only need to focus on what happens when x is larger than or equal to 0, and then we'll replicate for the negative part of the axis, we'll replicate the function with the appropriate inversion, right? So from now on, I'm going to study only this one here. Okay, the second thing we need to know is what is the domain of this function, because it involves a square root, okay? And that requires that the argument of the square root is larger than or equal to 0. That means that the x squared has to be larger than or equal to 1, or that the absolute value of x is larger than or equal to 1, right? So the domain of the function is the real axis minus, or the real numbers minus the interval -1, 1, right? Those are excluded because for those values the argument is 0, is negative, sorry. Okay, so given that we are going to study the function here, the only region we are going to consider in discussing this function is the region x larger than or equal to 1. All right, let me do first one analysis of this function, but it doesn't have any vertical asymptote because the function is never singular, okay? But there is an important information on as the asymptotic behavior with this function that we can analyze. Take for instance the argument of this function, right, and factor it out, right? So we factor it out like this. We factor out the highest power, okay? And when we do this, taking into account that x is positive, then this becomes x squared, the square root of 1 minus 1 over x squared. Okay, if x is very large, then this part here is going to be small, so the behavior of this will be close to a parabola. But let me tell you how we can get more information out of this. To begin with, we have here the square root of this, 1 minus 1 over x squared. And if we expand this using Taylor, remember we know this expansion for this binomial form, right, which is 1 plus alpha u plus ou, okay, when u goes to 0. So we know this expansion, okay? So our interpretation is going to be u is minus 1 over x squared and alpha is going to be 1/2, okay? And then we have this is equal to that, right? So we substitute here, well, and of course the limit we're going to consider is x going to infinity, because in this limit this term here goes to 0 and then it fits with this expansion here. So we substitute that and we get 1 minus 1/2 x squared, and this is 1 over this is negligible with respect to 1 over x squared, okay? This is OU, of course, when x goes to infinity, right? All right, if we introduce this expression here, what we get, we multiply this by x squared, we get x squared plus 1/2 plus O1. Oh, sorry, minus 1/2 plus O1. Okay, this is a very useful information. It tells us that when x goes to infinity, the behavior of the function is going to be that of this parabola. So it's going to get closer and closer to this parabola, and the rest is something that goes to 0, right? The difference between these two functions goes to 0, all right? So that provides a very useful asymptotic behavior for this function, all right? The next thing we need to analyze is what is the derivative of this, of f, right? So f prime, f is a product, so it's the derivative of the first times the second factor, which is x squared minus 1, then plus x times the derivative of this, which is x over square root of x squared minus 1. And if we reduce this to a common denominator, we have x squared here minus 1, the product of this and this, plus x squared, this x times x, divided by square root of x squared minus 1, which is 2x squared minus 1 divided by square root of x squared minus 1. Okay, given that x is larger than or equal to 1, then this is always positive because the denominator is positive and the numerator is always positive, right? So this is always positive, so we have an increasing function all the time. And one further observation, for x equal to 1, f prime goes to infinity, right? Which means that there is a vertical tangent, okay, at this point. It's a vertical tangent, not an asymptote, right? Actually, the value of the function at the point 1 is simply 0, because the square root of 1 minus 1 is 0, okay? So the function is well defined at the point 1, but the asymptote, the tangent, sorry, is vertical. So that means that near this point, right, near the point 1, the function is going to behave like this, okay, with a vertical asymptote like this. All right. We could analyze the concavity and convexity. We liked, although it's easy to infer. But anyway, if you want to calculate the concavity, you can do that. You can take the derivative of this. That's a quotient. So that is 4x times the square root of x squared minus 1 minus 2x squared minus 1 times x over the square root of x squared minus 1, which is the derivative of this, and then divided by the square of the denominator, which is x squared minus 1. If we multiply the numerator and the denominator by this square root, what we get is 4x times the square root, times x squared minus 1 minus 2x squared minus 1 times x. And in the denominator we have x squared minus 1 3 half, which is the product of this square root and this. Okay, the exponent of this is 1, the exponent of this is 1 half. So the sum of the exponents is 3 half. There is an x common factor here. Okay, so we have x multiplying 4x squared minus 4 minus 2x squared plus 1. Okay, and then x squared minus 1 3 half. And we simplify this. 4x squared minus 2x squared is 2x squared, and then minus 4 plus 1 is minus 3. So what we have is x times 2x squared minus 3, right, divided by x squared minus 1 3 half. All right. So what happens with the sign of this? Well, the sign is negative if this is negative, which means when x squared is smaller than 3 half, which means x is smaller than the square root of 3 half, then this is negative, which means that the function is concave. And if x is larger than square root of 3 half, then the sign is positive and the function is convex. It makes sense that it's convex for large values of x, because for large values of x we know that the behavior is going to be very close to this parabola, and parabolas like this with a plus sign here, they are convex. Okay, so it's going to be asymptotically convex, but it starts being concave. So there is an inflection point at the point square root of 3 half, right? So if we gather all this information together, this is what the function looks like. Okay, that's the picture of this function. So let's focus on the positive side, which is the only one that we've analyzed. Here you have the parabola, right? x squared minus 1 half, the one that is asymptotic to our function for large values of x. And then we have a function that starts at 0 at the point 1, okay, with a vertical asymptote as we derived, okay, so vertical, not asymptote, sorry, tangent, a vertical tangent. And then the function increases all the time. It is initially concave, makes sense because you have to curve to that side, right? So it's concave, but then there's an inflection point around this point here. It must be square root 3 half, and then it becomes convex because it's getting closer and closer to this parabola. All right, so this is the positive side, and in the negative side you have a mirror image of this inverted because the function is odd. So this is what the function looks like.